Okay, so let's start.
I don't understand your sketching.
All right, sorry. So if you're watching the video, yeah, we didn't record what? Related rates and
related rate difference.
and what is it? And linearization.
At least we know they can't shoot.
How you look scary with that beard.
So-
Sorry.
So
You look
it's
reminding me of
normal.
Judah.
So let's write down what each property means. Okay. What does the first property mean, everybody?
Point.
What does it mean? The point exists. What's the point?
Negative 35.
Well, take a look. There's the point right there. So I start by graphing that. Second part. Second part. Another.
0.03.
And finally.
Another point.
Okay, so 0, 3 is there, and 3, 0 is there. That's your starting point. Unintended.
Wow.
All right, next
It was
one.
not funny at all.
It wasn't.
Starting point, and these are all points. No? Nobody still?
No.
Okay. Let's take a look at this one now.
There's jokes.
That's the tough one.
That confusing.
Right? The absolute value is what confuses everybody, surely.
Yeah.
Because when I see the derivative is greater than 0, it means it is
Increasing.
increasing or positive. Good. So it's an increasing function. Well, where is it increasing?
-4 to -3, and
How do you know?
from 4, and then from all numbers greater than 3.
This is where we go back to algebra 2. If I have an absolute value function that's in an inequality, whoops, this is less than, no, greater than, sorry, I was right. If I have an absolute value, the way I can determine this absolute value, if we remember, is by doing what, Christian?
Separate two separate things. No.
Separate it, very good. And you separate it into the original, okay, and then you flip the sign and negate it. That's what that really means. So what does this mean? This is x is bigger than 3, right? X is bigger than 3. So as Christian said, from 3 to infinity, it's going to be increasing. And take a look from here, guys. From 3 onward, isn't this increasing? Look here. This is everything less than -3. So this is saying from negative infinity to -3. Sorry, -3. And from negative infinity over there all the way to -3, the function is increasing until it gets to its local max. And again, over here, it's increasing. I know, guys, it's tough. But you got to go back and think back to algebra 2. That's what these problems encourage you to do. Let's look at the next one. The next one says that the derivative at 3 and the derivative at -3 are both equal to. When the derivative equals 0, we have a what? A horizontal line. We could have a max or min, possibly, but we generally speaking have a horizontal line. I'm going to keep it next to me, leave it, just so you know.
Oh no, isn't that done, Johnson?
I don't care whether it is or not. You're not supposed to be leaving it here. The derivative at 3 and at -3 is 0. When the derivative is 0, yes, we have a horizontal line. So automatically, guys, you got to have to think about this. There must be a horizontal line there. Now, I don't know that there's a min or a max until I get to the next thing. That's what tells me that. So let's go into the next one now. This tells me that the function is not increasing, but now it's decreasing. Well, where is it decreasing? Well, let's take a look at this now. If I break this one up into its two parts, this tells me when x is less than 3,
Easy now.
okay, and when x is greater than -3. Well, when is x less than 3? If I draw a number line right now, here's 3, and here's -3. This one tells me x is less than 3. That's everything over here. Right? Everything less than 3 is shading in that direction. What's everything greater than -3? Taking this way and going like this, right? And shading. Well, where do they overlap? They overlap from here to here. So this property of decreasing this occurs in the domain from -3 to 3. Because I take the domain that I see here and break it into its two parts. Once I break it into those two parts, it's clear that they only overlap from -3 to 3. And take a look. From -3, which is here, to 3 along the x-axis, isn't this function decreasing the whole way? It's decreasing the whole time. Finally, the last part is concavity. When I see that it's less than 0, it's concave.
Zero?
Negative, down. Again, when the second derivative is negative or less than 0, it's concave down. This is concave up. So it's concave down for x less than 0. Take a look. Isn't this all concave down here? That's all concave down. Then for x greater than 0, it's all concave up. That's the last part there. x is greater than 0, it's concave up.
Wait, so pretty much you can do it with just the last two statements?
No, you need the last two statements, because without them, Kenny, without the last two statements, I could have drawn the exact same graph that would have worked, and it could have looked like this.
No, but doesn't it say it's continuous though? In like the direction.
Those are all continuous.
Really?
Sure they are.
But I mean, yeah,
Yeah,
but
the
like corners and cusps didn't count as like continuous. Which
They're continuous. What would that screw up? It's not the continuous
What
part.
about a function?
Differentiate.
The differentiation. We said that the derivative at 3 and negative 3 is 0, right? But here the derivative wouldn't exist. Okay, so we can't use that function. No big deal. Let's go ahead and try and find another function. What if I had one that looked like this? If I had this where it increased, then we had one that came through like this. It came down, went back here, then it went through again, and then it went through here. All those are good. They don't screw up any of my properties. I added in the property there in the middle, but it doesn't mean it's wrong. Theoretically, this is correct if you didn't have the last two values there. Do you see what I'm saying, though? They all do have a reason for being there. Some of them might not be as obvious right away, and some of them, at the end, you might notice by looking, and that's fine, and you should do that.
But I mean, well, also like, but doesn't the last two, yeah, but the last two defines it, right? It just says that there's two curves. Because there were two curves going down and up. Never mind. It's fine.
The last two,
No, what we're just saying in the last two. Just forget it.
if you can't understand yourself, I can't either, you know?
Yeah, that's the point.
Okay, figure it out, then get back to me. All right, let's take a look at another example. That was curve sketching there. The next one is slope fields. Oops, that's related rates. All right, so the first example for slope fields, you're supposed to do two things. Remember, you didn't have to solve the particular solution at all here. All you need to do is plot the fields. That's it. And then after that, describe the points for which slopes are positive.
Wait,
Okay?
No negative.
Positive.
Negative on ours.
It was negative on ours.
No way.
No, it was negative.
Negative.
Yeah.
Yeah, it was negative x or.
Yep.
What?
Go back, keep going now.
It doesn't matter. Negative x 4 doesn't change it.
Because that one.
Yeah, that one.
All numbers less than 1.
I gotta just check. The only reason I'm checking right now, I believe you, but I need to know because I need the second one. It might be wrong. Where's?
Oh shoot, I needed it wrong.
Let me just check to make sure I didn't mix these up for you guys. I did them in this order for a reason. That's why I get pissed at myself. I did.
I forgot the negative applies after.
That's weird. You gave us that one.
Yeah, but yours says negative. Mine says positive. Why did I make mine positive and yours negative? Let me go ahead and look. Let me see if I just forgot to change the word. Let me see my solution. Okay, no big deal. So we'll just do it with negative, no problem. So first, you start with your slope field. What x values is what I always want to start. What x values cause 0? 0. Again, if I plug in a 0 for x, it makes the whole thing 0. So when x is 0, which is along the y-axis, I've got horizontals already. Always start with horizontals. Then, what causes the y part to be 0?
Positive 1.
Y positive 1.
Subtract by 1.
Good, because when I want this to be 0, I could simply just say, set it equal to 0. Aren't you going to get 1? So this becomes 0 when y is 1. So when y is 1, which is right here and here, I also have flat lines. Remember, y equals 1 is a horizontal line this way. When x is 0, that was the y-axis there. At this point in time, you have to start plugging in. So if I plug in a value up here, like this is, for example, the point 2, comma, oh, whoops, not 2, 1, comma 3. 1 to the 4th is positive, 3 minus 1 is positive, this is going to be positive. Then I plug in the point here, 1, comma 2. 1 to the 4th is positive, 2 minus 1 is positive, also positive. Down here,
Negative.
negative. Over here,
Negative.
why is this still negative?
The y.
Because one, negative 1 to the 4th.
Negative 1 to
Because it's 0.
The power is positive.
Because of the even power, very good, Josh, because of the even power, x to the 4th, if you plug in the negative 1 for x to the 4th, you're going to still have positive 1. And then you're going to have a negative 1 here for the y value. Again, I'm sorry, a 0 for the y value, which gives you a negative 1 here. So again, if I plug in this, the easiest way to do this, if you're ever confused, is just list the points. Okay, that's the point there. So plug it in. Negative 1 to the 4th times 0 minus 1. Well, this is 1. 0 minus 1 is negative 1. It's going to be negative 1. So this is going to be negative down here. That's always your last resort if you have to. Here, at this point, would be negative 1, 2. Well, negative 1 to the 4th is positive. If I take 2 minus 1, it's still positive. So in this case, I notice positive and positive.
Yeah, I got it
So
wrong.
your problem said negative.
Less than 1.
So let's make sure I actually do it that way. So describe all points in the xy plane for which the slopes are negative.
When y equals
Negative 1, that's what I put.
when y is negative 1.
When y is 1 or less than 1. Less
Well,
than, less than
no.
equal to
Let's start by saying when y is 1, when y is 1 is 0, so that's wrong. Start by that. You got to be careful. When y is 1, guys, take a look. When y is 1, you get all these flat lines, don't you? That's 0. It's not negative. I want to know when it's negative only.
Y is less than
When
1.
y is less than
It
1.
doesn't equal 0.
And what was the x part?
It doesn't equal 0.
X doesn't equal 0. Let's discuss this.
So I thought it was like even if y is equal. Oh wait, no, because yeah, you're right.
Less than or equal to.
Okay.
Yeah.
It's not, and there's a reason for that. Again, if y is equal to 1,
Then it's
If-
0.
And 0.
if y is equal to 1, then it's a 0 slope. Take a look, plug a 1 in, it can't be 1. But everything below this, these are all negatives, aren't they? Except when what? X equals 0.
I thought it was actually.
Because when x equals 0, it's a flat line again. But everything else is going to continue in this direction. They're all going to look like that there. Okay, they're all going to look that way. So in this case, when y is less than 1 is one condition, everything below here, and x not equal to 0 is the other condition. You need two conditions. And you need the word and, please, not the word or. You need the word and. Now, it's a little funky, and that's what your next one's going to be on, so you might want to write this one down. If you have something where, see how everything is below the line, the same? What if I had like something, and you don't have to show for this example, what if these had been negative, and this had been positive? Then it's negative in this region, right? Everything down there would be negative, and everything up here is negative. So that would be an or statement. The reason being is, it's negative here if y is less than 1 and x is less than 0, that's this region, or in this region. It's two separate regions now. Okay, they're not the same as the last time. This region here is described by y less than 1 and x less than 0. This region up here is everything bigger than y1, so y is greater than 1 and x is greater than 0. So for this answer, for something like this, you would have your two conditions with an and then you'd have the word or, and the other two conditions with an and. So this region would be y is greater than 1, and, you could put and that way, x is greater than 0, or y is less than 1, and x is less than 0. Again, if you have two regions, it gets a little trickier.
Do all your answers have to work with y and x?
Yes, because the differential is a function of both y and x.
Okay.
dy dx is both, that's the
Yeah.
reason why. If it was just x, then we wouldn't even have differentials here. They're not differentials, it's just x. We can just do integration. Okay?
I only put a.
So just for an idea of that, so you guys know.
Y, I didn't know the function.
I gotta fix those typos.
Everything that you get finished.
All right, optimization. And I know we went over this in lunch with some people, but just so you guys can see. So for this problem, the first thing I want to point out is this. The printing area on the actual problem for the test, or where I got this from the practice test, was not given. This diagram was not given at all. So if that helps you, keep that in mind. You might have to draw that on your actual test. Now, the problem starts by saying you have 50 square inches of printing area. So right away, you should have written 50 right there to show that this printing area is 50. Okay, that's the first thing you got to think of. Next, a 4-inch margin at top and bottom. What is a margin? That means that's 4 and that's 4. A lot of you mixed up the left and right spots here. Okay, again, top and bottom margins. Left and right are 2. So I'm going to put a 2 there. And 2 is really that width right there. Okay? So that's my diagram. That's why I said, note, hint, use the diagram and indicate margins and dimensions with variables. So now, tell me, if I want to figure out to this problem, I want to know what the overall dimensions of the whole thing are. Overall dimensions to minimize the amount of paper used. What can I call the base?
Did you use A?
A?
You used A.
What did I use?
You used A and B.
No, I didn't. I didn't use
No,
any.
you used B and H.
B and H. So I'll call this B, Okay.
I thought A, that's why.
and I'll call this H. Now, when I did it with my solution a little while ago, I used the base of the printing area and the height of the printing area. It's the same thing. You can do it either way. If I do it this way, you get the same answer, but a different method. I'll try to stick consistent to what I did here, just so it's not confusing anybody. So with mine and my solution here, I called this B, and I called this H. Okay? I called the printing area B by H. So if this is B, what is this full length? B plus what? 4. Be careful. 2 on this side, 2 on this side. Remember, this is B, this is another 2, this is another 2, so it's B plus 4. Okay, again, this length is going to be B plus 4. What is the height going to be? H plus 8. Why is it 8? Because you have 4 up top and 4 inches down below, and this is H, so the actual height is H plus 8. Now, what helps you is the fact that you have the 50. Without the 50, you can't do this problem, because you want to minimize the overall area. Well, what's the overall area? Here's the overall area right here. This function right here is the overall area. It's the base, which is B plus 4, times the height, which is H plus 8. But I can't take the derivative because I have 2 different variables. So I have to use the constraint. And the constraint tells me that B times H is equal to 50. Because this is the base, this is the height, and they give you an area of 50 in the middle there. So that's where the constraint comes in. The constraint is the area of the printed area, which tells you that 50 equals BH. Solve for one of them. Does it matter? Makes no difference. You pick. Solve for H, and then replace. Keep those sounds to ourselves now. So the H goes in right there. Okay, the 50 over B goes in for H. Now, a lot of people actually got to this point. Most of you did. And notice, by the way, look at my nomenclature. This is just A, area. This is A of B. What am I saying here?
A times the base.
Not times?
A to the respective.
Good. That's a good way to say it. A is a function of the base now only. Notice, before, what was A a function of? The base and the height. But now that I've plugged in for the height, isn't it only a function of B? I only see B's there now. That's why I called it A of B, just so you know. And there's reasons for this stuff, not just madness. Now, when you see this, what should you do?
You should do your product.
Okay,
Not
or just
product.
FOIL first. FOIL first. A lot of people try
I wasn't-
product rule,
I wasn't gonna
which
do
is
that.
what you should do, actually, if you do this. But there's an easier way to do it.
Yeah.
If you want to take the derivative like this, sure, it's a product rule. That's A, that's B, use the product rule, but I would FOIL it.
It's a chain rule,
Are
though.
you really confused because you say one thing and then, I mean, I know that there's two different methods, but you say one thing and I'm just like,
Okay, so personally, I would not use the product rule because it's messy. If you FOIL this, take a look at what you get when you FOIL it. You can use the power rule on all these, can't you? Whenever you have a function that's a binomial and another binomial, I highly encourage you to FOIL first. Or even a trinomial and another trinomial, box method it, get your 9 answers in the box method, combine like terms, and use the power rule. It's so much easier. Okay?
you mean distribution, right?
If you have like, and you were taking the derivative of this, okay, you could distribute everything or just use box method.
Oh, okay.
Remember box method?
Yeah.
This is a 3x2 box here. Oops, you have 6 spots to it.
We never did that.
2x is here, negative 8 is
No, we
here.
did, but we never did it like.
We did it in the summer, guys. I know for this one. Don't try and argue with that one.
We did that,
Your
we did
matrix
that.
one.
We did that freshman year.
I was just
You know, we did that freshman year, Mr. Smith's class.
But you also did in the summer. I have it in my notes, guys. I teach all the stuff this year. I know for a fact we did. Either way, you saw at some point.
I didn't say that.
Now.
I was disagreeing with you. Oh my God.
I'm not saying you were, Kenny. Now, for this one, the hard part is this. And a lot of people mess this part up. When you FOIL, this is B times 50 over B. It just becomes 50.
I knew that.
Again, B times the
So
quantity
you say we'll go through tests.
To cancel, B.
50 over B is just 50 because they cancel. Please don't let that screw you up. Outer gives you 8B, inner gives you 200 over B, last gives you 32. Now, does it even matter, guys, if I combine like terms at this point? Why does it matter?
Because you
We
have
do
to,
derivative,
you
it
have
cancels
to
out
have.
the two constants. Cancels
Yeah.
out
Okay,
two
and the
constants.
50?
We can't, when you do the derivative, it cancels out the two constants.
Good, they drop off. They don't cancel out. Be careful, use your words right. They drop off. Again, these don't cancel each other, but when you take a derivative, constants drop off. So the derivative of this just goes away. You don't have to worry about it. So the derivative of this is 0. The derivative of that is 0. What's the derivative of 8b? It's just 8. The derivative of 200 over b, again, think of it as 200,
B to the
b to the negative 1, and then take its derivative. Negative 1 in the front times 200 times b to the negative 2. This becomes b to the negative 2. Again, the derivative of this is negative 200 b to the negative 2 based on the power rule. what is b to the negative 2? It's really over b squared here. And now, solve for b. The last part, which some of you still forgot, and did all the work right, and then saw this one on a few. You got b and you got h. That's great. But that's b and h for here, isn't it?
Yeah.
Because 5 times 10, what does that give you? That's the inner dimensions. What does this ask for?
Outer.
The, well,
Overall.
overall or outer. Yes, outer. Very good. Outer.
Couldn't we, I just realized,
So-
couldn't we know that it was already, 5 and
Oh,
10
yeah,
because
plug
of
it
the
in
square?
there, right.
Oh, everything will be, wait.
No.
No.
You said it directly.
Come on, Dan. Could have been 25 and 2, right? Well, maybe we didn't say that one.
Yeah.
Just
Deal.
plug in and then you get it.
So take your 5, add the 4 to it to get the base. Take your 10, add the 8 to it to get the height. You get, instead of 5, becomes 9. This becomes 18. 9 by 18.
I bet I have a pretty flower
Right.
in. You don't.
All right. So what we're going to do is another optimization problem. Let's go ahead and do that.
Oh.
Again, guys, I'm trying to help you. I wouldn't just waste the time on this for no reason, but clearly we need some more work to do. So one of the good examples of the book that I liked, and some of you might have seen this, I don't know if anybody actually did this one yet, but there was a good example that I saw for your homework.
Creepy.
Okay, here was a great example. The example is number 53 in your book, on page 230. If you happen to do this one already, then it might be a little review for you. The problem says the following. And if you didn't do it yet, please write it down.
Do I have to write this in the following also?
Two positive numbers have a sum of 60.
Hands done.
What is the maximum product? By the way, this is a perfect multiple choice for AP. This is exactly what a multiple choice would be like, and I'll explain why. Maximum, what is the maximum product of one number times the square of the other?
Some X, not
And they give you 5 choices here. You don't really need to write the choices down, but it doesn't matter, guys. Okay, for now, I'm going to leave the choices out.
Optimization is maximum.
Why is it optimization? Because you're trying to find the maximum
Yeah.
product, the maximum product. We're still going to use derivative, yeah? Again, because optimization. Whenever you guys see max and min, think right away optimization, first derivative set equal to 0, that kind of stuff.
Friday workers, please come to the main office. Friday workers, please come to the main office. Thank you.
Right?
Who's? Oh, you know what?
Junior.
No, that's all juniors. They take no juniors to come to the office.
What? In the middle of class?
Yeah.
Yes,
That makes no sense.
Why
Friday
would
workers. Oh.
Friday retractor.
Friday freshman workers, please come to the main office. Friday freshman workers, please come to the main office.
You're the small guy you're trying to.
That's why they haven't held something now.
It's that terrible.
I was like, what?
They don't know what's in the beard.
Just the darkness.
Could be a
Okay.
be black hole.
We're told right away that the sum of 2 positive numbers, it's very key that they're positive because we might get multiple answers here. We have to reject the negative. The sum of them is 60.
That's our constraint.
Okay, so what is that?
X plus Y equals 16.
Sure, x plus y equals 60. Now, Kenny, I can't just make that statement because what's x and what's y? I have to start by defining, right? So we'll call x what? One of the numbers? Okay.
Okay. Is it,
And then what's y going to be?
Another number.
The other number?
But is that just for them to know, or just because?
Only reason I'm writing it this way is because in a minute you're going to see the second part is a little trickier.
Okay.
And I normally wouldn't write that, but you'll see here now. It says, what is the maximum product of one number times the square of the other? One number, product means multiplication, and it's one of the numbers, so maybe x or y, times the square of the other. Times the square of the other.
So, like, if I count the x, so it would be x times y squared.
Very good. Now, my question for you is this. Christian, what about this? That's one number times the product of the other, isn't it? So which one do I choose? Okay, good. It does not matter
Just
here.
make sure you get this
The reason being is one of them is one number, the other is the other. If you set it up this way, you'll get two numbers, right? For x and y. You set it up this way, you'll get the reverse numbers. But it's the same thing because we picked x and y arbitrarily. So if you get x equals 5 and y equals 10, then if you did it this way, you get x equals 10 and y equals 5. So it does not matter which way you choose here. Is everybody clear on that? Okay? Again, one or the other. Does not matter. Now, I cannot take the derivative of this product because it's x and y. So what should I do? Gary?
I thought you can't do that one thing.
Where, Joss? In the? Very good. In the constraint. Remember, I can't take the derivative here because of the fact that it's two different variables. We're not using implicit with optimization. We apply our constraint. So using our constraint, solve for one of them. Which one should you solve for?
X.
X, please. Because if you solve for y, you got to plug it in and then FOIL and square it. Solve for x.
You plug in y, you can cancel off on the one.
Now, what am I going to write here? Instead of p, I'm going to write p as a function of y. Because now I know y is the only variable for myself. Okay, the only reason I'm writing that is because now x is gone. Once I see that I've written it that way, I know that I can then take a derivative. So what should I do?
Distribute.
Distribute? What do you mean distribute? I see a product. Why don't you use a product rule?
Because why would I use a product rule if I can use a power rule?
Very good, Kenny. Good answer. Good answer. Again, here, this looks like a product rule, doesn't it? Distribute the y squared and choose a power rule. So rewrite the function. We're not taking the derivative yet. Rewrite it as 60 y squared minus y cubed. Again, just simply take your coefficient of y squared and distribute it to both of those. It makes it easier to take the derivative because now the derivative of this, p prime, is just going to be
20y minus 3y squared.
See how easy that is now? So much easier than taking the product rule. Okay, product rule is a bit of a headache.
Distribute the square.
Whenever you have something that's a product rule, Jasmine, if you could distribute something to make it into one long trinomial or binomial, I would do it. So I distributed the y
Oh my
squared.
gosh, man. 3 people would.
No, I used the power rule. Power rule.
My dad
You
would-
meant power, I hope, right?
Yeah, power.
Okay.
My dad.
But yes, use the power rule there. What do I do with the derivative? Set it equal to?
0.
Why?
Because you're looking for the maximum.
And what? So what? What does that mean? Think back.
First derivative has to equal 0.
Critical points.
Good, because of critical points. Good. When critical points are existing, when the first derivative equals 0, which is the occurrence of a max or a min. Again, remember that. Have the fact that it's increasing, then decreasing causes a max. If it's decreasing and then increasing, you have a min. So in this case, we want to go ahead and set it equal to 0.
So, wait, hold on. So first derivative is the critical point, second derivative is the curvature. What's the derivative?
There's no like term for it. The second derivative is really actually inflection points and curvature, yes, but inflection points you're looking for. Third one, there's nothing that you're going to look at. Yeah. So in this problem now,
0.
Add 3y squared.
y equals 0 is one of them, but what would that? Would that minimize or maximize it?
Neither.
Sure it would.
Really? Depending on, actually, you're right, depending on.
Well,
yeah.
I'm sorry. First of all, you'd reject it because it says they're both positive numbers, actually, right? Sorry. The beginning says two positive numbers, and x or y equals 0 is clearly a solution because I can go like this to start this problem. I'm going to factor out a 3y, and I'm going to be left with 40y minus y squared. Does everybody see that? Okay. Minus y, thank you. Why am I going crazy there?
Oh, I
I can
see.
take out my y. Again, I see that this both have a y in it, so I can factor out a y to start. They both have a 3 in it. 3 out of 120 leaves me with 40. 3 out of 3 leaves me with a 1 there. So I'm just factoring out GCF.
Yeah.
So one of my solutions, as Kerry said already, I make a t-chart, one of my solutions is y equals 0. The other solution is y equals 40. Well, which is minimizing and which is maximizing?
We don't know yet.
We don't know yet, but we kind of do know that this is rejected because it said two positive numbers. So y can't be 0. So if you're going to reject this and you have one answer left, and this is multiple choice, people, there's a good chance that this does maximize the function, not minimize it. Again, we're trying to find the maximum product, right? The maximum product. And if you test the first derivative, and you look at the first derivative on number line, and you run this through the number line, here's what you're going to see. You're going to have critical point there at 0, critical point at 40. Okay, you're going to have a positive function there and a negative function there. So if you plug in a point like 1 into the first derivative, take a look. 120 minus 3 is 117. Isn't that positive? Plug in a number like 5. I'm sorry, 5. A number like 50, which is above 40. A 50 here, you're going to have a number here that's around 6,000?
Oh, yeah.
1,000? 6,000 here, or 60,000, sorry. A 50 here would give 60,000. This is going to be 50 squared, though. 50 squared is 2,500, and 2,500 times 3 is 7,500. So plug me in 50, you're going to get 6,000 minus 7,500.
You show 60,000.
Let me just check, hold on. 0, 0. 5 by 2 is 0. We could. Why am I doing math wrong in my head now?
It's because you're human, that's why.
Christian messes people's minds by making them believe.
Sorry, 6,000. I apologize.
No, I gotta double check this.
So 6,000 minus 7,500, you're going to end up with negative 1,500. Showing
Is that
me,
wrong in your head?
120.
I was saying 60,000.
Oh, okay,
And it was 6,000.
That's just 60,000.
How did I get it?
It's 60,000.
Now you're really messing with me. Because I just did long multiplication. I got that.
believe it though.
So
Yeah,
again,
boy, if I-
increasing, decreasing. Therefore, this must be a max. Now, am I done though? What does the problem say?
The other, gotta find the other number.
No, it doesn't say that. What does it say?
Positive product?
The maximum of the product.
Find the actual product. So you need the other number, and then you got to find the product. Remember. So this is y. If y is 40, take a look. If y is 40,
Plug in different string.
plug. Very good. Don't plug it back in over here. Plug in the constraint. Because look, if y is 40, what's x? 20. 40 and 20 gives you 60, right?
40.
Again, we got y equals 40 as our answer. If y is 40, then this is going to be 20 automatically. Well, we got to go back now and find the max product of the number and the square. Well, which one did we square on our original function? We squared y, right? So you got to make sure you square y and then multiply by 20 to get the product. Again, it says, what is the maximum product? So take your 40, plug it in there. Take your 20, plug it in there. 40 squared is 1,600 times 20 is 32,000.
Let's double
Nice,
check.
Carrie. That's correct.
40 square plus.
Gary, you might have him when you were a little kid, just like you want to play the streets with the students. Now,
I don't think sure.
so wait, so the only reason why you plugged it back into the x plus y equals 60 is just so that you can get the other variable to find the product?
Quicker and quicker. I could have plugged it in, Kenny. I could have plugged it in somewhere else to try and figure. Actually, no, I couldn't have. What am I saying?
That's the only thing you
I
can
couldn't have plugged it in here. No, absolutely
do. You
not.
don't know b. You have two
Exactly.
variables.
Absolutely. So by default, you have to.
Yeah.
Okay. I'm trying to check the time, guys. It's Monday. What is
Oh,
the,
it's
Like around 108.
105, usually 104, it's like 12.
32,000.
Let's do one more. We'll do one more problem. We got like 5 minutes. Let's try and at least get through an example of another one. So again, the idea here, remember, that when you get x and y, you got to answer the question being asked. What do you think choices would be for this example? 40, 20, those are probably other multiple choices for this problem. Because people get the answer for y and they see 40, right? Boom, they circle it. They're done. But it didn't ask for that. It asked for this number, 32,000.
Do the one that you guys need.
Oh, God.
I told Christian asked for an optimization problem, and I told him to find the minimum material needed to build the showcase outside of Savio Hall, assuming that the depth was twice the height, or half of the height, or whatever it was. Did you do your dimensions? Did you measure it out or no?
We
Yeah,
tried to.
I tried to do this. I mean, I got the dimensions, but then I was
The height was
He
like
gave
6
up.
inches. Did you
Yeah.
use me?
6.
All right, let's do it. No, let's do that.
You were
That's fine.
Gary was with you?
No, put it on good.
I thought it was how it go.
No, we were there.
For,
I was doing the interviews for the freshmen, unfortunately.
Right.
I mean, fortunately, I loved it.
I'm surprised.
So here,
He ditched the.
You don't do this, you can't get it.
you know that like showcase right outside of Savio Hall with all the stuff in it? So that was the question I asked him. I said, Christian, assuming the volume is held constant, so that's what you have to figure out, which is the volume, obviously. Okay? Assuming the volume is held constant and the width was half of the width was half of the length, or does it matter right now, honestly?
So that you
Okay.
go last number two?
So I say the first thing I gave, I told him that the width was half of the length in this case. That was the first condition. I said that the volume had to be constant, and for him to find the minimum amount of material to make it and find those dimensions, which is realistic. So take a look at the volume now. What did you end up getting? Have any idea for the volume? Like,
4 for the length,
okay,
2 for the width, and approximately 6.
Of what?
So that's not the dimensions of our answer, that's what you saw, which gives us a volume of
Wow, 36, no, 48.
48.
48.
Wait,
So-
but why? 'Cause isn't the width, isn't it half, so?
No, these were what, this was what he saw out there. These are not our answers, Kenny. This is what he
No,
saw. I know, it doesn't meet the constraint, I understand.
Okay.
This is what he saw out there, okay, that's all.
Yeah,
So
'cause
what
you
this
said
tells us,
half a length of the big
what
one.
this tells us is simply that the volume was 48, that's all, and it was just cubic feet. Because each tile was a cubic foot, that's what you use, right?
I'm saying, I ran into the same thing with Kenny, I got confused with that constraint.
With this constraint right
The
here,
constraint up there.
up there.
Being like half the width.
Doesn't it make it, yeah.
Here's the reason you use it. Here's the reason why. You say 48 equals LWH, right?
Okay.
Automatically. This is my constraint. So I can solve for LW or H. Stay with me, I know. Both of you. LWH here, you can solve for one of them. Because what I want to do, I want to minimize surface area. Surface area is the sum of all 6 faces, right? So this face is L times H, and then there's a back one. So there's, remember how we did this last time? There's 2 LHs, there's 2 WHs,
And there's two WLs.
and there's 2 WLs. So I can't take the derivative of this because I have 3 variables, Christian. Okay? So I can solve for one of those variables here. I can solve for one of those variables here and then use it.
But how does that help?
Watch. W equals half of L.
No, what I mean is, what I'm confused about is that, like, I thought the constraint will assist you in the volume itself. Why isn't the volume?
The constraint, what are you minimizing? The surface area. Whatever you're minimizing or maximizing is your like objective function, the function you're going to change. Whatever is given to you is your constraint. This was given. In his case, he measured it, but it was given in that sense.
But yeah, okay, I get that, yeah.
That's the tough part. So let's go ahead and plug in. For W, we're going to plug in half of L. Or you know what I'm going to do instead? To make the numbers a lot easier on myself? Why don't I just go like this, guys? Doesn't that make more sense? Do I want to work with 1/2 all over the place when I'm taking derivatives?
No.
I'd rather have a 2. So say that L is twice the width instead. So wherever I see an L now, I'm going to put 2W. Okay, I know. I can put 2W squared, not 3W.
I know. I was changing. I thought it said plus, and I looked at it.
So here I've got, now I see that everything's in terms of W and H, isn't it? So it's still a problem. I don't want H. So I got to solve for H here. But solving for H here, I get H equals 48 over LW.
We have 2.
But I still have LW again.
Squared. H. So,
Say again?
would be 48 over 2W squared.
Because L is really equal to 2W, isn't it? So take this other constraint, combine with this constraint, plug in the 2W for L here. Then the height is really 48 over 2W times W. So wherever you see an H now, you're going to put 48 over 2W squared.
Christian's just like, why?
Oops, not, sorry.
Saw some-
By the way, shouldn't I simplify? 48 over 2 is really 24 over 1. So I'm going to replace all my H's with 24 over W squared.
It's just W. Well, in that case.
Yes.
Well, pretty much all the
They're all going to reduce to over W there. Oh, the last one?
No, last
No.
one would be. It would just be like that. What, Christian's looking at me?
Remember, guys, this 2 on the outside is still distributing the whole thing. So at this point in time, you're going to start canceling. You can go on, solve. What are we going to get for this?
I know.
2 times this is 48
People love me.
over W plus 24 over W plus 2W squared. Now, this 2 is on the outside. I'm going to set this equal to 0, right? So is the 2 on the outside going to do anything, actually? Why? We can divide by 2. Remember, isn't there really 2 out here? Because I have 2 front panels, and I have 2 top and bottoms, and 2 left and rights, really. That's where that 2 came from in the beginning. But once I have a 0, this 2 is going to kind of drop off anyway. So at this point in time, I need to go ahead and take the derivative before I can do this
How
stuff.
can you make it 0 before you did it?
That's what I just realized. Dang, I took a step ahead. Put the 2 there, first write it, then take the derivative and drop it off. So the derivative of this 2 again, 2 has no effect on the problem whenever it's derivative. And then the derivative of this, drop the 2 off. And you finish it. But you would get a width there, you would. I'm curious to see what you would get when I finish it. Tomorrow, just so you guys know, tomorrow we're starting substitution method, then we have after school. The substitution will take at least 2 periods. At least. So we're only starting there today, and we're finishing after school. It might even take us into Thursday, just for a heads up.
Okay.
Oh, the,